again. This is the second part of this problem. I've just found all the solutions to a particular equation. I'll just go up and show you the one I've done. I've just found the solutions to that top equation, and now we're going to factorise the expression into real factors. So let's just go down and deal with that. So these are the solutions. We're now going to find the factors. So the factors are, those are the solutions. So we're going to get z minus, now I'll put them in order. I'll do the i's first. So z minus I, z minus minus I, which is plus I. And then I'm going to have z minus e to the I pi by 4. I'm going to write the corresponding one, that is z minus e to the minus I pi by 4 next to it. And then I'm going to get z minus e I 3 pi by 4 and z minus e to the negative I 3 pi by 4. Okay, and we're just going to try and write that. This is linear factors, but these are not real because not all the coefficients we're seeing here are real numbers, and that's what we're after. These two will do easy enough. I'm just going to take a little bit of an aside to show you something you're probably familiar with, but anyway, it won't hurt. If you have z minus e to the I theta into z minus e to the negative I theta, as we have both here, positive and the negative, and here, then something particular happens. So I'll just do this multiplying out. What you get when you multiply these out is, so this is, maybe we should do it in a different colour. This is like a little aside. This equals z squared minus z e to the I theta minus z e to the negative I theta plus e to the 0. Z cos theta plus I sin theta minus z. Now, on cos of negative theta plus I sin negative theta. And e to the 0, of course, is just 1. Minus z cos theta minus z I sin theta minus z. I'm just multiplying out the first bracket and the second one. Now cos of minus theta is the same as the cos of theta, and the sine of minus theta is minus the sine of theta. You can confirm that with the cast diagram. A negative angle, positive angle have the same value for the cosines, and similarly for sines, the negative angle has a negative whatever the positive value is, so that you get this slight difference between the cosines and the sines. Because of that, cosine of negative theta is the same as the cosine of theta. But then when we come to do minus z against the sine of negative theta, that is, sine of negative theta is negative the sine of theta. So this becomes a negative, and times that gives you the positive there. We've got minus the z multiplying it, but this is minus the sine of theta, so you get a minus and another minus to give you the plus there, plus 1. And this then simplifies to, you got minus z cos theta minus z cos, so minus 2z cos theta. You get minus zi sin theta plus zi sin theta, and then you get, which cancels itself out, and you get plus 1 on the end. And this is the standard thing that you get when you're doing z minus e to the I theta minus e to the minus I theta, when the angle there is the positive or the negative of the other one. And that was a long way to go around, excuse me, to say that's what I'm going to use in this case here, where I've got that situation happening here and here. Okay. blue. My factors then are difference of two squares, so that's z squared plus 1. And using this, when I do that, I'm going to get z squared minus 2z cos of pi by 4 plus 1. And then again using that idea at the second time, you get z squared minus 2z cos, this time of 3 pi by 4 plus 1. This equals z squared plus 1. Z squared minus 2z. The cos of pi by 4 is root 2 over 2. Squared minus 2z. The cos of 3 pi by 4 is negative root 2 over 2. 2's cancel, so we get minus root 2z plus 1 plus root 2z plus 1. And that's the final thing where it's now all in real factors because all the coefficients are real numbers. This part that I did in the middle here, which I spent a little time on, you don't really need to write that down every time you do these things, but you absolutely need to have it well in your head that when you have plus the angle and minus the angle, that this happens when you're multiplying that. Okay, that